Hello everybody and welcome to today's lesson on geometric sequences and series. Today our objective is we will investigate and apply the properties of geometric sequences and series to solve problems, including finding the first n terms, finding the nth term, and evaluating summation formulas. In our last class, we talked about arithmetic sequences and determined that in an arithmetic sequence, there is a common difference between each two terms. So what is a geometric sequence? In a geometric sequence, there is a common ratio between each two terms. What does that mean? If we take two terms and we calculate a ratio between them, so in this case 6 divided by 3, that is 2. And if we take the next two terms, 12 divided by 6, that is also 2. And 24 divided by 12 is also 2. Then we have a common ratio, r, and that ratio is 2. So let's look at a couple more examples and see whether they are geometric sequences, maybe arithmetic sequences, or whether they're neither. We're going to first try out if this is a geometric sequence. So negative 4 divided by 1 is negative 4. 16 divided by negative 4 is also negative 4. Oh, we might be onto something. Negative 64 divided by 16 is again negative 4. And so, yes, this is a geometric sequence, and the ratio r is negative 4. Excellent. Now let's try our next one. First, let's see if we have any common difference. 2 and 5, that's 3. 5 and 10, that is 5. And we don't even have to keep going because we already see that the difference is changing. Now let's see if we have a common ratio here. 5 divided by 2, that's 2.5. 10 divided by 5 is 2. Also, the ratio changes for each pair of elements, so this one is neither. And on to our last example here. Let's see, what do we have? We have 3 plus 3 is 6. 6 plus 3 is 9. 9 plus 3 is 12. So we have a common difference, which makes this an arithmetic sequence. Just like in an arithmetic sequence, we also have a rule in a geometric sequence to find the nth element. And the rule is like this: a sub n is equal to a sub 1 times r to the power of n minus 1. So you see similar elements in this rule. We have an a sub 1 that we always need. Here we have our common ratio, and now our common ratio doesn't get multiplied by n minus 1 as in the arithmetic sequence. Here it gets raised to the n minus 1's power. So, and in our example here, we have 4, which is our a sub 1. And now let's find our r. 12 divided by 4 is 3. 36 divided by 12 is 3. 108 divided by 36 is 3. And 324 divided by 108, without your calculators, you guessed it, it has got to be 3, right? So r is 3. And that means we can now write our rule. A sub n is equal to 4 times 3 to the power of n minus 1. This is our rule. And if, for example, we wanted to find the 10th term, a sub 10 is equal to 4 times 3 to the 10 minus 1 power, which is 4 times 3 to the 9th power. And if we plug this into our calculator, we get a sub 10 is equal to 78,732. That's a pretty big number. And as you will continue to see in this lesson, numbers tend to get big, very large in geometric sequences as we continue to multiply by a constant ratio. How can we write a rule for a geometric sequence if we have a term and the common ratio, but the term we have is not a sub 1, like in this example? Let's first remember a rule. It's a sub n is equal to a sub 1 times r to the power of n minus 1. And now we're going to use the term we have as our a sub n and solve for a sub 1. So a sub 3, which is equal to negative 12, is equal to a sub 1 times negative 2 to the power of 3 minus 1. N is 3 in this example. So negative 12 is equal to a sub 1 times negative 2 squared, which is, of course, 4. And now we divide both sides by 4, and we get negative 3 is equal to a sub 1. And now we can write our rule. A sub n is equal to negative 3 times negative 2 to the power of n minus 1. How do we write a rule for a geometric sequence if we're given only two terms? In that case, we're going to resort to a technique that we have learned a long time ago in Algebra 1, which is solving a system of equations, in this case by substitution. But first, let's set up our rule using each of these two elements separately. So a sub n, if that is 3, then 18 is equal to a sub 1 times r to the power of 3 minus 1, or just r squared. And we can also say negative 486 is equal to a sub 1 times r to the power of 6 minus 1, because this is a sub 6. And cleaned up, this means this is equal to a sub 1 times r to the 5th power. Now we have two equations with two variables. Remember, one equation with two variables we cannot solve, but if we have two equations and two variables, we can solve it. And the way we do it is we're going to take one of the two equations and solve them for one of the two variables and then substitute. I'm going to recommend to always use the equation that has r with the lower exponent and solve that one. So we're going to divide both sides by r squared, and we get 18 divided by r squared is equal to a sub 1. And this is what we're now going to substitute into the other equation for a sub 1. And that gives us negative 486 is equal to 18 divided by r squared times r to the 5th power. Now the r squared and the r to the 5th power we can simplify, and we get rid of this one completely, and this exponent goes down to r cubed. Negative 486 is equal to 18 r cubed, and now we divide both sides by 18. Negative 27 is equal to r cubed, and now we can take the cube root of both sides to get negative 3 is equal to r. And now that we have that, we can use our r to find a sub 1. I'm going to go back to our first equation. 18 divided by negative 3 squared is equal to a sub 1. 18 divided by 9 is equal to a sub 1. So 2 is equal to a sub 1. And now we have all the elements we need to write our rule, which then looks like this now. A sub n is equal to 2 times negative 3 to the power of n minus 1. Well done, you guys. And now go ahead and watch the second part of this tutorial where we'll talk about geometric series.